Alright, so today we are going to look at area of regular polygons. These are notes for homework 11-4. So the first thing we need to look at is what is a regular polygon. Can anybody tell me what you remember about what a regular polygon is? Come on, prior knowledge. What makes a polygon? Closed figure. What about the sides? Straight sides. So what makes this a regular polygon? Well, it's a polygon, but what makes it a regular polygon? Well, a square and an equilateral triangle are regular polygons. What's special about those? All the sides are equal and? All the sides are equal and? Sorry? All these interior angles here are equal as well. So a regular polygon just means all sides are equal, all interior angles are equal. It doesn't mean it has 6 sides. It could have 6 sides, but it could have 1,000,000 sides. It's anywhere from 3 sides to however many you can think of. So it is important to know the different parts of a polygon in order to find its area. So as we look at this, I would like you to highlight the distance from the center to any side. So the distance from the center to any side right there is called the apothem. That's A-P-O-T-H-E-M, apothem. So this right here is the apothem. And what happens when you draw this line from the center to a side, technically, well, let's talk about that in just a second. Let's talk about what this is. This they're going to call a radius. You're like, well, the polygon's not a circle. Do you notice what they've done to this polygon? They've inscribed it inside of a circle. Every vertex on this polygon is touching that circle. Any regular polygon can be inscribed inside of a circle. So I can take from the center, and if I draw to a vertex, that's always going to be a radius of the circle. So if I drew this in, the radius, let me write that a little bit better. So the radius goes from the center to a vertex. If I drew a second radius here, it creates this triangle because both radii are the same. So I'm just going to go ahead and draw another one. So if I drew another radius, what kind of triangle do I have? Isosceles triangle because the radii are the same. And whenever you take this apothem becomes the altitude of that isosceles triangle. And what does that altitude do to the side here? It cuts it in half. So one thing that you need to know about the apothem is it cuts the side of that polygon into 2 equal pieces. That's going to become important here in a minute. Then they have given you this area formula for a regular polygon. A equals 1/2. A is your apothem, and P is your perimeter. I like to use a capital P, and quite frankly, you're going to see me writing the equation this way. A equals 1/2 capital P times A. Why? Because that's how I learned it, and so can't teach an old dog new tricks. Just saying. So how are you going to memorize this? Even if your Arizona Merits did give you formulas, which they don't, they're not going to give you this one. So what's the mascot at your school? A husky. What do huskies have on their feet? Paws. So this is half a paw. Not P-A-W, but half a paw, right? So you can think of that. It might be helpful. It might not. But let's go ahead and actually see how do we actually apply that formula. So number 1 and number 2 are the easiest problems on the page. You wish that all your problems were this easy. Look at what they've given you. What does this represent? That's your apothem, isn't it? The apothem comes from the center to a side, so that's your apothem. A radius would have looked like this. A radius would come from the center to a vertex. So they have not drawn a radius in. Yes.
So for like this part, it doesn't matter.
It doesn't matter. No. Right. Order doesn't matter. And then what is this? Yeah, but what is this on the polygon? What does it represent? A side length. Isn't it a side length? Okay. So this is going to represent our side. Those are the only two things I need in order to apply the formula. So I skipped a little bit here. How do you find perimeter of any figure? This is perimeter. How do you find it? Add up all the sides. So what do you know about the sides of a regular polygon? They're all the same. So if I knew one side, what could I do on this particular figure to get the perimeter quickly? Multiply by 6, right? So on number 1, I don't have a hexagon, I have a triangle. So how am I going to find the perimeter on the triangle? Take this and multiply it by 3. So I'm going to apply the formula. A equals 1/2 PA. And we're going to find the perimeter within the formula. So we've got equals 1/2 times. And instead of perimeter, I am going to multiply my side times 3. Can you even see that? Yeah. Goody goody. And then my side length is 24.2 feet. And then times our apothem, which is 7 feet. So then you're going to take out your handy dandy calculator, and on your calculator you're going to do the perimeter first. So take your calculator out, and I want you to take 3 times 24.5, 24.2, let's get the right numbers in there, and then multiply it by the 7. And then finally, how do you do the 1/2? Divide by 2. Your calculator should read 254.1, and I'm going to do 0 because we're going to round to the nearest hundredth, and you're missing the hundredths place, so we're going to add a 0 in there. Feet times feet is feet squared.
So you always multiply by sides.
Correct. So if I had a 10-sided figure, we'd be multiplying by 10 here. And that's the only thing that kind of differs in the problem. Anybody not get this on their calculator? Because if not, if you don't ever speak up, you're going to do the whole day wrong. You got to know how to use your calculator when you get home. I am going to allow you to use your own scientific calculator on the test, which is Wednesday. You may not use a graphing calculator, however. So you either need to bring in your own scientific calculator that you're comfortable with, or you get to use mine. I won't teach you how to use mine because you've used them before. You should know how to use them. So if you need to practice, you can come in before school, whatever, or get a scientific calculator that you're comfortable with. What you cannot have are those graphing calculators, because you can put in a bunch of stuff in there you're not allowed to have. She said, smiling sweetly. So then you're going to do this one on your own. This is the only one you're going to do on your own today. So I will try not to burn down the school by covering up this. Oh, that didn't work. You do your own thing while I mess around up here. Now if you smell anything burning, you let me know right away. This could be bad. Share your answer with those around you. All right, so Skylar, what'd you get? Okay, 851.2. Oh, it totally was burning this. Can't put anything up there. No, there's no closer.
Wait, what part's burning?
No, it's nothing. Yes, totally just burned my book. Okay, are there any issues with finding those? Yes or no? Yes or no? You got to talk to me. Okay, so we're comfortable with those. Let's move on to what happens if you are not given the apothem and the side length, because those are easy, right? Given a calculator, just plug them in. The only hard part is finding that perimeter. So you've got to highlight, please, these steps here. So we're going to use most of these steps. I'm going to adjust the steps a little bit because I like my way better on one of these. But the first thing you're going to do is create a right triangle by drawing the apothem and the radius. So as you look at question number 3, all they've given me is the apothem, correct? I have no side length. I have to have the apothem and the side length in order to apply the formula. So I'm going to go ahead and draw a radius, and that's to any of the vertices. So I'm going to draw it there. I don't need the radius to solve the problem, but what it does is it creates this right triangle. I don't like the triangle written that way, but I'm going to do a couple things. What does this apothem do to this side? Cuts it in half. So I'm going to call this half x and this half x. Won't an entire side length equal 2 x's? True or false? True. So I have to actually find 2x and my apothem, which I have, and then I can apply the formula. So how do we do that? Well, let's go back just a little bit and look at this picture up here. That looks like a piece of pie, doesn't it? Technically, I've only drawn 1/2 of the triangle down in number 1, or I'm sorry, that's number 3. If I draw a second radius, I get this big slice of pie. Agreed? If I drew a radius to every vertex, how many slices of pie would I have? 6. Would you agree that this whole thing is 1/6 of the entire polygon? Well, we're going to use circle theory and right triangle theories here. Because this polygon is inscribed inside of a circle, I can easily find using circle theory, because this is a central angle of the circle, isn't it? The whole circle has how many degrees? 360. This is a central angle. It would be 1/6 of 360. What's 1/6 of 360? What's 360 divided by 6? 60, right? So this whole thing here is 60. If this is an isosceles triangle and this altitude here bisects the side, doesn't also bisect the angle here? So if this whole angle is 60, what's this little angle here? 30. So we're going to use that same thought process here, because it says, okay, well, so we created our right triangle, which I did here, but I'm going to redraw that right triangle here because I don't like it upside down, and I don't like them small. I like them big so I can write in them. So here's my big triangle. You're going to have to learn to write small, though. And I flipped it. My apothem is here, so this is my apothem equals 5 centimeters. And then I've labeled this side here as x on the picture. What I need to do is find this angle measure here. So number 2 on here says find the measure of the interior angle, but they tell you to do this stuff. We're not going to do that. So you're going to cross this out right here. I don't like any of this. I'm going to cross that out. And instead, we're going to do the following. If I'm going to find this angle, I'm going to really look at it as if it's a whole central angle. So we're going to find that whole central angle. You're always going to take 360 degrees, and you're going to divide it by the number of sides, because that's going to tell you how to partition that out. So you're going to divide it by your number of sides. And then you're going to take all of that because I don't want the whole central angle, I only want half. Then you're going to take that and divide it by 2. That's going to find that central angle, or that middle angle, that interior angle. So here, we're going to find the angle by taking 360. We're going to divide it by, how many sides on this figure? 6. Well, I'm not going to put sides in there. I'm just going to put 6. And then we're going to take the whole thing and divide it by 2. Always divide by 2. So again, what's 360 divided by 6? 60 divided by 2, 30. So our interior angle here is 30 degrees. Now, that brings us to step number 3. Then you've got this triangle. So you're either going to use special right triangles, 45, 45, 90, 30, 60, 90, or SOHCAHTOA if it's anything other than 30, 60, or a 45 degree angle. Plus, we could also possibly use Pythagoras' theorem to find missing side lengths, but that's not the case here because I only have one side. Is this a special angle? Yes or no? Is 30 degrees a special? Thank you. Thank you for participating. We're not going to get anywhere if we don't participate. So then we're going to use our 30, 60, 90 pattern. So let's review that. What do I put underneath the 30, 60, 90? 1, no, red, 3, and then 2. Then make your fractions, right?
No, it's 3 red, 2.
No, it's 1, red, 3, 2. So relearn your pattern. Trust me. Then what's across from 30 degrees? X. So we're going to put an X across or underneath the 1. Then if this is 30, isn't this the 60? So what's across from 60? Well, that's an A. So 5 centimeters, right? So we're going to put 5 centimeters here. And then what's across from the 90? Nothing. A blank. Don't put X here. The X is already here. They both can't be X's. If there's nothing here, you put nothing here. You don't have to fill everything in. So then this becomes step 2. We are going to solve, well, let's use this color. We're going to solve this ratio right there. Don't we cross multiply and solve? If I cross multiply, I get x radical 3 equals 5, and that's centimeters, but I ran out of room. I want to solve for x, so I am going to divide by radical 3. Isn't that what my x equals? Doesn't it? Doesn't x equal 5 over radical 3? Now some of you are going to say, well, you can't have a radical in the denominator, right? Is this a final answer? No. So don't worry about the fact that there's a radical in the denominator. Just leave it. Don't change it into a decimal. Leave it exact. Aren't I trying to find 2x, however? I don't want x. I want 2x because this distance here is 5 rad 3. This distance here is also 5 rad 3. I want 2x, which means I have to multiply this by 2. So my 2x is actually equal to 10 over radical 3. So this is my side, and this is my apothem. Now I'm ready to apply the formula. So, no, we're not done yet. I told you these are hard. So all we did was find the side. Well, you're writing small. I told you guys write small. So then step 3, I'm going to put right here, A equals 1/2 PA. So we're going to plug in equals 1/2. We're going to find our perimeter. How many sides are there on this? 6 sides. So 6 times. Then you're going to put in for your side length the 10 rad 3, so 10 over rad 3, times your apothem, which they gave to you was 5, and I don't have room to put in my centimeters, so sorry about that. So, how do you put this in your calculator? What part of this looks ugliest? This right here. So I'm going to tell you what it is, and then I'll show you on the calculator. Those of you watching the video won't see the showing on the calculator. But you're going to do this first. So you're going to take 6. Well, actually, I would do this one first. You're going to take 10 and divide it by radical 3. If you have a display calculator, you can do 10 divided by rad 3 equals. If you have this calculator, you have to do 10 divided by 3 radical equals. So it's different. And then you're going to multiply by 6, then multiply by 5, and then divide by 2. So let's see what we get. All right, so your area, your area is, and it's actually a squiggly equals, 86.60, and then this is going to be centimeters times centimeters, so we get centimeters squared. Okay? Now we're going to do it again. The more times we do it, the better you're going to get at it. So let's look at number 4. Okay? So this time 4 is a triangle. So we're going to start off with the same process. Haven't they given us the apothem? Right? So you're going to draw in a radius. So I'm going to draw the radius in over here. That creates a right triangle. Here's my right triangle. So off here to the side, step 1, I'm going to redraw that triangle bigger and relabel it. So my apothem is 18 millimeters. And then when I drew that, well, that apothem, doesn't that cut this side into x and x? Right, it splits that side into 2 pieces. So I'm going to label this side here as x. Again, my radius is blank. Leave it blank here. That's okay. So then we're going to find our central, or this angle right here. So the angle always is equal to 360 degrees divided by how many sides? 3 sides. And then all of that's going to be divided by 2. What is 360 divided by 3? 120. If you zone out on me, you're killing your education, just to let you know. So what's 120 divided by 2? 60. So is that a special angle or not? Yes. So this is 60 degrees right here. And that means we're going to use our 30, 60, 90. So let's use that pattern again. 30, 60, 90. What goes under 30, 60, 90? 1 rad 3, 2. So some of you need to relearn that. What is across from, so if that's 60, this is 30. So what's across from 30? 18. What is across from 60? X. And what is across from 90? Nothing, so leave it blank. So then our step 2, we are going to cross multiply and solve this right here. This one is actually pretty simple. When I cross multiply and solve, don't I get x equals 18 radical 3 millimeters? But do I want x? I want that whole side length. What's that whole side length? 2x. So we're going to multiply this by 2, and we're going to multiply 18 by 2. So my entire side is equal to 36 radical 3 millimeters. Don't break into a decimal. So now I have a side, and I have an apothem. Can I apply the formula? Isn't this easier the second time around? Right? So then our formula says A equals 1/2 PA. So 1/2 times, we're going to find our perimeter. To find the perimeter, how many sides do we have? 3. So we're going to do 3 times our side length we just came up with, 36 radical 3 millimeters. Times our apothem, which was given, of 18 millimeters. So in your calculator, what do you think you're going to do first? you're going to do this first. So you're going to do 36 times, in the rinky-dinky little calculator I have, you have to do 36 times 3 radical equals. On your display calculator, you can just put it in exactly as you see it. In fact, you could probably put this whole thing in as exactly as you see it, just don't do the 1/2 yet. So I'm going to stop and show you my calculator. Okay, so we get an answer of area is approximately, because we are estimating, 1,683.55 millimeters times millimeters is millimeters squared. Are we good? Any questions? Okay, so then let's move to number 5. So for 5, we again are given the apothem. So for the 3rd time, I'm going to draw in a radius. Radius is always from the center to vertex. Katie, are you working with me, or are you just looking? Okay, you need to work. Get your hands out of your shirt. Let's go. You're ruining your education. Just let you know. All right, so when I do that, y'all are hilarious. So I've got the apothem here, so that's one piece that I need. I've got to find x, really 2x, so I can get my side length. So step 1, I'm going to redraw that triangle. So my apothem is equal to 10 inches. And then, oops, this is x. Again, I don't know my radius, and I really don't care. It doesn't matter. The radius is just there to create that right triangle. I am going to find this angle, however. So now this is time 3 that we've done this. To find the angle, it's equal to 360 degrees divided by what? Not 3. Where'd you get 5? It's the number of sides, and then all of that is divided by 2. So what is 360 divided by 5? 72. What's 72 divided by 2? 36. So is that a special angle? No. So whenever it's not a special angle, then we are looking to use some old hippie caught another hippie tripping on acid. See, it doesn't go away. So then we have to look at our angle of reference, which is 36 degrees, and look at the side lengths and determine what they are. So according to my degree of reference, what is x? Is it the side opposite, the side adjacent, or the hypotenuse? This is the opposite, isn't it? What about the 10? Is it the side adjacent or the hypotenuse? It's adjacent. So what uses O and A over here? O and, yeah, it's got to be tangent, right? So we are choosing tripping on acid. That means that we're using tangent. So we've got, so then step 2, we're now into step 2. So we are choosing tangent. We know my degree is 36 equals, and it's tripping on acid. That tells you how to set up your ratio. So my opposite is x, and my adjacent is 10 inches. What do I do with this? We turn it into a proportion. So I'm going to put this over 1, and then I'm going to cross multiply to solve. So when I cross multiply, don't I get 10 times the tangent of 36 degrees equals 1 times x is x. That's awesome. I solved for x, but what do I really want to solve for? 2x. So I'm going to multiply this side by 2 and this side by 2, because that really gives me my whole side. So this right here is going to represent my whole side, 20 tangent of 36. So now I have my side, I have my apothem. Can't I apply my formula? Now, before you even start, those of you, first of all, look at your calculator. If you've got a display calculator, not a graphing, but if you've got a display calculator, it should show DEG up here at the top of your calculator. If it doesn't show DEG, if it shows RAD or GRAD, you're in the wrong mode. Those of you who have a graphing calculator, go to the upper left part of your keyboard and press mode. Check the mode of your graphing calculator. It better say degrees. If radians is highlighted, you need to cursor over, light up degrees and hit enter. And then we're going to practice with the square root of 36 here in a minute. So the first thing we're going to do though is we're going to set up our equations. So step 3, area equals 1/2 PA. So 1/2, we're going to find perimeter. How do I do it? Okay, how many sides? 5. Times my side length is, I'm not going to put 2 times 10, I'm going to put 20 tangent of 36 degrees. And then times my apothem, which is 10 inches. And this is in inches, by the way. So then, isn't this the more complicated part? So it should be. So if I were you, I'd do the tangent of 36 first, then times 20, then times 5, then times 10, finally divided by 2. All right, so let's go back before we hit the calculator. So we have a couple questions. Where did I get this from? So we use this ratio, correct? Are you looking at me cold? Okay. So when I cross multiplied here, I got x. Cross multiplied here, I got 10 tangent of 36. You are doubling both sides because I want 2x, the whole side length, right? So the 2 gets multiplied out here, not to this, because the tan of 36 is that decimal that we just found, the 0.725465. We don't want to double that. Well, okay, that does end up getting doubled, but we don't want to double the 36. You want to double 10 times the tangent of 36. The 2's on the outside. You have to multiply the 2 to the 10. That's where the 20 came from. You cannot multiply the 2 to the degrees.
You don't multiply the whole thing like you couldn't find 10.
No, you don't distribute it either. Okay? Any questions before we go back into the calculator? All right, so let's punch in the calculator and see what we get. So how do I remember the order? The last thing I ever do is divide by 2, for 1. I always start with the perimeter typically, because I can multiply these in whatever order I want to. So I'm going to take that complicated part and multiply it out first, and then multiply by the 10, then by the 1/2. So I just started here, tan of 36 times the 20 times the 5.
So you just hit the bottoms and also right.
Correct. But make sure you hit equals first before you divide by 2. And so then your area should come out to be approximately, because we're estimating, 363.27. And that's inches times inches, so it's inches squared. Okay? So we're going to skip 6 and flip the page. So we've got 2 more to do. We're going to start with 7. Stay with me. You can do this. Stay with me. All right. So 7 no longer gives you the apothem. So we no longer have an apothem. We have the entire side. We must have the apothem and the side. So you're going to draw in the apothem, which is always from the center, perpendicular to the side. So this is my apothem. I still am going to draw in the radius because I want that right triangle. I don't need the radius though, so I'm going to leave it blank. So step 1, I'm still going to find that angle that's right here on the triangle. So I'm going to redraw my triangle because I like it bigger so I can see it right side up. I'm going to find this angle. My apothem is always here vertically. And then what does the apothem do to this side here? It cuts it in half. So if that side's 8, then isn't this 4 and isn't this 4 inches? So that means this side here is 4 inches. You can't forget to cut that in half. Now we're ready to find out that angle. So the angle is equal to 360 degrees divided by what? Where'd you get 5? number of sides. Then we're going to take all of that and divide it by 2. So what's 360 divided by 5? Divided by 2. So again, we get not a special angle. So we're going to put the 36 in here. So we're looking at using some old hippie caught another hippie tripping on acid. Right? So we have to label our sides. So if 36 is my degree of reference, what is 4 inches to that? Opposite. And what is the apothem? It's adjacent. Isn't that going to be TOA again? So we know in step 2 that we are going to be choosing tangent. We know our degree is 36 degrees. We found that earlier. Equals, we are tripping on acid. So our opposite was the 4 inches. And our apothem was our adjacent. So we are going to turn this into a proportion, and we're going to cross multiply and solve. This is a harder one to solve, requires 2 steps. So here we go. So I'm going to multiply these together first. So I get A times the tangent of 36 degrees equals 1 times 4 is 4 inches. Is everybody okay with that? Aren't I solving for A? Okay. So then to solve for A, I want to divide both sides by the tangent of 36 degrees. This is going to create some strife on you because you've got to put, so A is going to approximately equal, you've got to put this in your calculator correctly. All right? If you have a display calculator, you just have to put 4 divided by tan of 36, end your parentheses and hit enter. 4 divided by tan of 36, hit enter. If you have a calculator like mine, I'm going to show you how to use it. So give me a minute. So we get an apothem of 5 points, what did I say, 5.1, and that's inches. So now I have my apothem. We have our side length from before. We're not using the 4, we're using the 8. So I've gathered everything I need. So step 3, apply your formula. A equals 1/2 PA. So I have 1/2 times, how am I going to find perimeter? How many sides? So 5 sides times our side length, which is 8 inches, times the apothem, which we just found, was 5.51 inches. That's going to be approximately, let's plug that into the calculator, that shouldn't be too much of an issue for you. So I'm going to do 5 times 8 times 5.51, enter, and then divided by 2. What'd you get? What'd you get? 110.20 inches times inches is inches squared. Did I hear somebody get something different? What'd you get? So follow me again. Do 5 times 8. Oh, yeah, you got a roll. All right, so can we do the last one? No. We're going to. Here's the last one. We're going to do number 12. Last one. The reason why I'm choosing number 12 is this time they've given you the radius. So, given the radius, this is equal to R. We've got to put our apothem in here. So our apothem would go here. And then our side length, that apothem cuts the side length into x and x. So this time I don't know my apothem or my side length. I have to find both of them. This is the one time I have the radius. I'm still going to redraw my triangle. So for step 1, I'm going to redraw this triangle. I'm going to flip it because I like my triangles this way. So my apothem is going here. This is x. And then my radius is 12.5. feet. So we're still going to find our central, or that angle right here. That's equal to 360 divided by what? How many sides? 6 sides. So divided by 6, and then all of that divided by 2. What's 360 divided by 6? 60 divided by 2? Oh, phew, 30 degrees. That should be nicer because it's less work. So we've got a 30-degree angle. So we are going to use our 30, 60, 90 pattern. And we're going to put under here the 1, radical 3, 2. And then we're going to follow what's under 30. So what's under 30 is what? X. What's across from 60? A. And then this time we actually have something across from the right angle, and we need it because we don't have any numbers in the denominator. So that's our 12.5. Right, Josh? Making choices. So we're going to actually have to solve 2 different ratios here. I'd start writing if I were you, because you've just given up on your education. Step 2. I'm going to take this ratio with the 2 over 12.5. So 1 is to x as 2 is to 12.5. Cross multiply. Don't I get 2x is equal to 12.5, and that's in feet. I'm going to stop you right there. Don't we want to solve for 2x? Why solve for x when 2x represents the length of a side? So stop there. You've actually found your side length. So that one's done. So then third one, we're going to use the ratio rad 3 over a with the 2 over 12.5. So rad 3 is to a as 2 is to 12.5. Again, we're going to cross multiply. So I get 2a is equal to 12.5 radical 3, and that is in feet. But this time I do want to solve for a. So I'm going to divide by 2. And a ends up being 6.25 radical 3 feet. Now I have my apothem. Can't I apply my formula? Last step, you can do it. Step 4. A equals 1/2 P times A. 1/2 times. How do I find perimeter? 6 sides. Yep. 6 sides times my side length is 12.5 feet. My apothem is 6.25 radical 3 feet. This time, which one appears to be the ugliest? This one here. So I actually, if I were you, would put this in my calculator first. So if you have a display calculator, you can just put that in exactly as you see it, hit enter. Then multiply by 12.5, then by 6, and then finally divide the whole thing by 2 after you hit enter. But on my rinky-dinky calculator, I'm going to do 3 radical, then times the 6.25, and then follow with all of that. So here we go. Hang on. When you guys, your answer should be, if you want to check it, approximately 405.95 feet squared. Yeah, hang on just a minute. No.